The latest innovation that will be the focus of today's podcast is micro-LED, light-emitting diode, a new display technology that is poised to completely change how we interact with digital content. The evolution of display technology has been rapid and transformative. In the early 2000s, LCD, liquid crystal display, emerged and quickly became the dominant display technology, providing bright, sharp images and low power consumption. A decade later, it was followed by OLED, organic light-emitting diode, which brought deeper blacks and improved contrast ratios, making images appear even more lifelike. OLED also enabled new applications like the new curved screens that are popular with gamers. And this year, in 2023, it is expected that more than 50% of all smartphones sold will ship with OLED displays, and that's up from 30% in 2019. But there is something even newer, which, if you haven't seen it, you soon will. Hello and welcome to Advantest Talks Semi. I'm your host, Keith Schaub, Vice President of Technology and Strategy at Advantest. Micro-LED, despite being relatively new, is already being hailed as the future of display technology. Micro-LED displays, like all semiconductors, require testing to ensure their performance and quality. However, in addition to electrical testing, display technology must also undergo special optical testing. Therein lies the growing challenge. Micro-LEDs are less than 100 microns in size, allowing for incredibly high pixel densities. But that means the testing just got a lot harder and a lot more costly. To take us through this exciting micro-LED display journey, we're joined by Advantest's own Kotaro Hasegawa, Applied Research and Venture Team Lab Leader in Japan, an expert in display technology working on next-generation innovations that help to enable these new markets. Hello, Kotaro, and welcome to Advantest Talks Semi.
Hi, Keith. Thanks for having me.
So, Kotaro, you've been following this display technology for quite some time with Advantest. Let's first talk about the underlying technology. Can you give us a brief overview of LCD and OLED technology? What are the main differences and benefits?
Keith, as you said, LCD and OLED are two of the most popular display technology in use today. While both produce high-quality images and video, they differ in several key ways that make each technology unique. And the interesting example is their use in smartphones. LCD display have been a go-to technology for smartphones for many years. However, in recent years, OLED displays have become popular, thanks to their ability to produce more lifelike image. The current display technologies are limited in their physical size. It is difficult to go beyond 70 inches with either LCD or OLED.
Okay, so tell us about this new micro-LED technology. What are some of the cool new features?
Micro-LED is the next evolutionary steps for the display technology. It is cutting edge and poised to reshape the world of the digital displays. Unlike traditional LCD and OLED, micro-LEDs use tiny LEDs that are less than 100 microns in size, which is about the size of the human hair. They can all be individually controlled, provide a shape image down to the smaller detail. They are also faster and brighter, and they consume much less power, which is a key environmental benefit. And become to how they are manufactured. They can be used for new applications like transparency. Moreover, micro-LED-based technologies display could be used as a tiling scheme to build over 100-inch display by tiling small display unit for luxury and signage purpose TV.
So, Kotaro, that's interesting. You mentioned the transparency, which I think is pretty interesting. That sounds very intriguing. What sort of new applications would use transparency?
Imagine AR, augmented reality applications, where you need to overlay important display information on top of your real-world view. When people hear AR, most people think about gaming, but there's many new and evolving applications outside of gaming. For example, retail displays. Imagine if all the windows use a transparent micro LED, would give new meaning of the term window shopping. or if the entire side of the building is architected with micro-LED. Because of how they are manufactured, you can tie them together to create extremely large signs, or industrial AR displays for manufacturing and assembly. This will provide operators with real-time information about the production processes or machine status. A car mechanic is a good example. Imagine the mechanic wearing the AR glasses can be guided and assist the live with the important information overlaid. You could suddenly upskill workers for a variety of industries. Or for the medical field, enabling doctors and nurses to see the digital information could be used for training and for the actual surgeries.
Kotaro, that's pretty interesting. Me personally, like you said, I have a VR headset, but mostly I use it for games because it's still too big and bulky to wear any length of time.
Exactly. Imagine if it is 10 times lighter and lasts 10 times longer. That will change things a lot.
10x improvement, that sounds significant. How does it do that?
That's one of the more exciting promises of the micro-LEDs. Studies have shown them that consume 90% less power than the OLEDs in high brightness displays. They use GaN, which are just more stable and energy efficient materials. Their much better power efficiency makes them ideal for any type of application, especially wireless applications such as AR and VR.
Kotaro, where are we with these micro LEDs in the market and what's the outlook?
Still in the earlier stage and not yet widely available for commercial applications. However, it is all about the change. According to the recent market report, global micro-LED display market is projected to grow from the current $0.1 billion to over $20 billion by 2026. That is a compound annual growth rate of the 89%. The growth is being mainly driven by the demand of the high resolution and power efficiency displays for all the type of the applications like we've been discussed here: smartphone, wearable, automotive, and AR, VR. This new technology is poised to disrupt their industry and expect to become a major player in the display market.
That's pretty substantial growth. What sort of new challenges are facing this new tech since it's so new?
The two key challenges right now are manufacturing and cost, and they go together. Micro-LED are very small, like we said, the size of a human hair. This market then challenges the fabricate and assemble in high volume with the required quality because they are small size. They require high precision manufacturing to ensure uniformity and high quality across the display. It's all technology doable. It just takes time to set up manufacturing lines with the new higher precision equipment and processes. And it's good to the cost challenges. Currently, micro-LED are more expensive to produce than LCD or OLED. Part of this is due to the manufacturing challenges, but part of this material cost is higher. As the new manufacturing advancement become online, the economies of the scale will kick in and those costs will start become down, which in turn will open it up for mass consumer applications.
That makes sense. Basically, we're looking at a new technology that's just coming online, so it's a little bit expensive right now, and there are a lot of new tools and processes that have to be put in place. Sounds like that's the situation.
Exactly. It's not a question of if. That's a question of when.
I also imagine that there are new test challenges that we are working on as well. What are some of those?
With this smaller size and a higher pack density, the quality requirements are increasing. When we look at these new displays, there are millions of the LEDs. If one of them, the LED, has an issue, the human eyes notice it. It means there's lots of the testing required for mass production. It's a similar cost challenge that the leading-edge processors have. New processors shrink, so you get more transistors in the same given area. In this case, we get more LEDs in a given area. The test cost will go up unless you do something differently.
Okay, so we've got a cost challenge. What about the actual testing of the micro LEDs? How are they tested?
There are two key testing aspects of the testing display technology, which is electrical testing and optical testing. For electrical testing, We are measuring the diode characteristics and look at the things like voltage, current, and power consumption. One of the Advantest's greatest strengths was HVM, high volume manufacturing, and massive parallel testing, with the industry used ATE, automatic test equipment, for that. But we also need to measure the optical behavior. So now we're talking about the things like brightness, wavelength. Think about if you are buying the new TV, you look at that picture and decide if it's good or not. It is the same idea.
The optics obviously is challenging. How do we test the optics?
Currently, there are two typical optical testing methods. Photoluminescence test. It is a method of measuring the trend of the physical properties of the emitting layers as an optical response. It is a good approach to see the relative optical behavior, but it cannot detect electrical defect. Electroluminescence test. Force current and measure optical output by using the spectrometer. It is closer to real-world use case, but it is slow. As an example, brightness levels are critically important and key parameter that must be tested.
Okay, so then how is that actually done?
We do that wafer test. There are two typical ways to test brightness level in HVM. The most popular method uses an integrating sphere with a spectroradiometer. There's also 2D approach by using the CCD cameras. Neither method works well for micro-LEDs because they either get too costly or there isn't enough accuracy. It's a difficult challenging problem, but one of the Advantest has been working on that quite some time. The solution needs to meet all technology requirements, but just as importantly, to fit within a cost envelope.
Sounds like, pardon the pun, that there might be some light at the end of the tunnel.
Yes, we think we've come up with a new breakthrough approach that uses the embedded test cell approach. The breakthrough was coming up with the way they leverage the parallel testing for both of the electrical and optical testing. This embedded approach solved both of the technical hurdles and cost challenges, and we feel it could really help to accelerate the adoption of the micro-LED in the market.
That sounds intriguing. Is there anything more you can say about it?
What I can tell you at this phase is that is a completely new parallel approach that tested both an electrical and optical in the single touchdown. We look at the older approaches, but it was not meeting our needs because of technology and cost limitations. Early pros have been successful, and we have started working with prober vendors to integrate this at the test cell level, which will provide another efficiency boost.
Great. Seems like it's going to be exciting to see how the micro LED market develops in the coming months. And it'll be interesting to see the new applications, maybe some transparency, maybe some larger displays at CES in 2024. Well, Kotaro-san, thank you so much for joining us today and sharing your insights on the emerging micro LED market.
Thank you, Keith, for having me. It was a pleasure.
So that does it for another episode of Advantest Talks Semi. Be sure to subscribe to this podcast to stay up to date on the latest technological innovations in the semiconductor industry. If you would like additional information on the latest with micro LED testing, please contact Advantest. See you next time.